All right, congratulations, ladies and gentlemen. You have made it to the final unit of the year. So we've gone through various topics from the idea of using a force to get things moving, to what happens when things are moving, to what happens when things kind of wobble back and forth and what they generate. And we finally landed on the last topic, which is the idea that things not only can just move forward, backwards, up, down, they can also turn or twist or rotate. All right. And in fact, our entire last unit is kind of a combination of two things. It's a combination of review, and it's a combination of just a slightly different type of motion we're going to talk about. All right. So our last unit of the whole year is rotational motion. Okay. Now, just a kind of a brief little background, it's kind of written right here, is the idea that so far in our class, we've talked only about one type of motion, and that is what we refer to kind of as linear motion. And that's basically the motion that we experience the most in our daily lives. It's whenever we're moving forward, backward, going up, going down. All right? Now, in reality, there are two ways we can actually get something to move. We can have it move via linear motion, or we can also have it rotate. All right? Now, rotation can look very different compared to the normal, everyday linear motion, but we're going to find out that things that are rotating actually still follow the same rules that linear motion does. They simply have to kind of adjust it slightly in order to adapt to the fact that we're spinning that object, not just having it move forward or backward. All right? Now, this entire video is focused on the idea that all of the linear topics we've talked about so far have a rotational version that we're going to kind of spend the next week and a half covering. All right? So this whole video is kind of just talking about the different kind of basically twin of the linear version of that quantity. All right, so let's start with at the beginning of our story. And when we started our entire class, we started with the idea of things moving. And we did graphs, we kind of looked at how things speed up, slow down, stay the same. But in all those cases, there were four physical quantities we cared about, and they were all part of kinematics. All right, now in the linear kinematics, we talked about the idea that we have things like displacement, velocity, acceleration, and time. Well, in rotational kinematics, as we're actually going to find that you can use kinematics for things that are spinning, congratulations, you have the same things, except now we've put a fancy word angular in front of all of them. So for rotational motion, things that are spinning, instead of worrying about their displacement, we worry about their angular displacement. And we're going to define what those are real quick, just that. And we're going to revisit these later, each unit. So this is just kind of a general definition. But basically, all angular displacement is, it's how many radians I've turned. So literally, that would be a measurement of like how many degrees I've gone around. Okay, and I could say, oh, I measured this. I'm watching this wheel spin. This wheel has spun a total of maybe 900 degrees, and that would be a measurement of angular displacement. All right. Now, angular velocity is pretty much just like the idea of what normal velocity is, except instead of measuring how fast I'm moving forward, angular velocity is literally measuring how fast I'm spinning. All right, that's all it is. It's how fast I'm spinning at any point in time. And kind of just like velocity was displacement over time, angular velocity is going to be angular displacement over time. So that would be the same thing as just saying the change in the angle divided by time. All right. Now, the third thing that we're going to talk about is angular acceleration. And oh my gosh, amazing. If acceleration is how fast I'm speeding up or slowing down or how much velocity I'm gaining every second, angular acceleration is how much angular velocity I'm gaining every second, or how fast I'm speeding up or slowing down while spinning. All right, and we're going to find out that even though these things can be kind of strange, we have the word angular in front of it, literally they behave the same way. All right, now the last piece, of course, is time, and congratulations once again, just like we talked about before, time doesn't really care what you're doing, it just keeps moving. So in this case, for linear kinematics and rotational kinematics, time is still the same. It's still just how long something takes. All right? But what we're going to find out, and that's going to be the next video for tomorrow, is the idea that, in fact, rotational kinematics acts exactly the same way as linear kinematics. So we're going to find out we have rotational kinematic formulas we can use that let us predict how things can move when they're spinning. All right? Now, we jump from kinematics and the idea of things moving to the idea of what we need to do to get those things to move. So the next thing we talked about in this class is forces. All right, this is one of the few times, well, I want you to write something down that I don't tell you to write down. If you could, real quick, I want you to write out what Newton's second law is. Just kind of type it in there so that you have it in front of you. All right, so hopefully we know from our experiences and kind of working with Newton's second law that that's the idea that the net force on an object just equals mass times acceleration, or the way I like to look at it, just the acceleration of an object is equal to force divided by mass. Now, in rotating systems, you still actually have to follow this rule. Newton's second law does apply to things that are turning, but what we're going to find out is that instead of using acceleration, force, and mass, rotating objects kind of have their own versions of those things. All right? So the first one is going to be force. All right? Instead of using force, when we talk about a rotating system, we actually have to apply something we refer to as a torque. All right? And the best way to think about that is basically it's a turning force. All right? You're applying a force and you're causing something to rotate. That's all torque is. And we're going to define that in a bit more detail later on, but basically, we'll just say torque is just a turning force. And we're going to understand exactly what that is because some of you have probably worked with items that produce a torque. You hear about it a lot if you work with cars. We're going to explain exactly what that is. Now, mass. You would think that mass would be the same regardless. But actually, for rotational motion, for things that are rotating, there's a little bit more to it. And in fact, we don't just talk about the mass of an object that's spinning. We talk about something referred to as its moment of inertia. And this is a very strange concept that we're going to go into much more detail when we talk about Newton's second law for rotation. But for us, a moment of inertia is basically the amount of mass a turning object has and where the mass is located compared to the turning point. All right. Now, right away, that seems rather strange, and I can understand when you look at that and you're like, that doesn't make a single bit of sense whatsoever. What do you mean related to the turning point? And what we're going to talk about here is we're going to see the idea that the moment of inertia is basically the idea that something that's really massive can be harder to turn. But something where it has a lot of mass and that mass is far away from the turning point is even harder to turn. And the best way I can describe this for you is go into your house, grab 2 cans of whatever you have available, and I want you to try and start spinning around with these 2 cans really close to your chest. You'll find it's probably not very difficult. Then I want you to start spinning around when you take your arms and you spread them way out wide. All right? And what you've done is you've actually increased your moment of inertia because you have spread out your mass. It's farther away from the turning point. All right? And if that doesn't make a ton of sense, that's totally fine. We're going to keep reviewing it later on, I promise. All right? And then, of course, the third piece is acceleration, which in rotational terms is angular acceleration. And congratulations, we already talked about that. Remember, that's just how much I'm speeding up from spinning or slowing down when I'm spinning. Okay? So I'm not going to write the definition because we're having a pup. Nice. So we go from kinematics and forces to now we go to our next piece, which was we talked about energy. All right, and we'll know from energy that anything that's moving has some type of energy. Remember, specifically it has a type of kinetic energy. And things that are rotating are exactly the same. All right, something that is turning is moving, which means it has kinetic energy. But what we find out is that there are actually now 2 flavors of kinetic energy. You have kinetic energy of things that are moving forward, backward, up, down, left, or right, and that is linear kinetic energy. But you also can have kinetic energy of things that are spinning. All right? And that's exactly what we have right here. It's referred to as rotational kinetic energy. And literally all it is it's the energy of an object that is spinning. All right? And honestly, if you think about it, any sort of object that's spinning, it makes sense that it has kinetic energy, because if you think about it, you can use a spinning object to transform that energy into other types of energy. I can use a spinning object, maybe I have it set up so that I have some wheel spinning, and I tie it to a rope. That spinning wheel can be used to pull up something and give an object gravitational potential energy. All right? Now, Rotational kinetic energy does not follow any new random rules. Literally, it still follows the exact same rules that everything in energy does. That's what makes it kind of nice. So the law of conservation of energy must be conserved. It can still be transformed into other things, and we're going to talk about that in more detail when we kind of focus on the idea of rotational and linear kinetic energy. All right. Now, the final piece, the final thing we kind of talked about that relates to rotational motion was when we started to talk about the idea of momentum. All right. Remember, momentum for us, the most important thing was the idea that anything that was moving wanted to keep moving, and that kind of tendency was referred to as momentum. All right. Now, of course, that was linear momentum. We just didn't know it at the time. And the other type of momentum we have is referred to as angular momentum. And angular momentum is basically a very specific quantity that says that any object that is spinning wants to keep spinning the way that it is spinning. All right. Now, that is a very simple definition for something that's actually quite complex, especially if you start to kind of head out into the universe and start to look at some of the stranger things the universe has to offer. But for our intents and purposes right now, all angular momentum is basically the tendency of a spinning object to keep spinning. All right. The tendency of a spinning object to keep spinning a certain way. Now, I know I blasted through these in hopefully 15 minutes. We'll see, because that's all the time I have on the recording thing I use. But we are going to go through all of these in more detail later on. And in fact, we're going to start by going into more detail about rotational kinematics. But the reason we usually leave rotational motion to the end is because it's basically taking everything we've learned throughout the year and just looking at it through a slightly different lens. So all the rules we've talked about, all the laws, all of them still hold true for things that are rotating. You just have to slightly change your perspective to match it to a rotating system. All right? So with that being said, ladies and gentlemen, that's where we're going to stop this particular video. I promise we're going into much more detail with all these terms over the coming days. So if you have any questions, send me an email. Otherwise, have a great rest of the day.